Hello, good morning, people. Should be live in just a minute. Once the YouTube delay is done. And hopefully, it looks like my audio is working, and hopefully everybody can actually hear me. I'm now seeing the delay catching up. Waiting on confirmation that the audio is working, and it looks like I can now be heard. Hooray! I have a voice and a platform on YouTube. I'm now a YouTuber, yay! I'm so exciting, so exciting. Okay, so let's take a look at what we're going to work on today. I'm just going to start the dev server and give you a quick little look at the Hoverboard site. And if you're not familiar with Hoverboard, essentially it's a conference website template. It was primarily built for GDG DevFests, but there are a number of other conferences that are using it now for their own conferences as well, which is pretty neat. I took over maintainer of the open source project last year, and I've been working on slowly updating it. Originally, it was on Polymer 2. Recently, I updated it to Polymer 3 and converted it to TypeScript. Kind of the next main project I'm working on with it is upgrading from Polymer 3 to LitElement. So this is essentially what the website looks like. You can scroll down, it shows you some stats, it shows you speakers, you can see a schedule, look at all the kind of normal conference website type things. And so today my plan is to convert this about block here into from a Polymer component into a LitElement component. This is a relatively simple component. It doesn't have a lot of interactivity, but to keep this content from taking 4 hours, that's boring to wait that long. So we're gonna do a simpler one that we can convert pretty easily. Let's see, if I jump to, I don't even have a code editor open. Ooh, and my computer's chugging. This is like a 5-year-old MacBook Pro, so it is not as speedy as I would like it to be. So the specific component is called about block, so I'm going to create a branch for that. And I'm going to open that and open the code base in VS Code. Oh yeah. Nice little delay. I usually don't have video processing going at the same time as I'm running a bunch of node processes, so this is lots of fun. Okay, so about block. I don't have that file yet, which makes sense because we're about to write it. So if we look at the about block, it's essentially, so there's some styles, nothing too fancy. There's some HTML that basically hard codes some content. It has a couple of paper buttons that you can click on, and then it triggers, it calls a action and throws some data into the Redux store. Fairly simple. So that's a quick overview of the component that I'm going to convert. Let's get started. I'm going to do pretty much all of the work in the VS Code terminal, so that it's a little easier just to see it all running while I'm looking at code once the terminals are all up and running. Okay, so for today, I'm going to focus on doing more test-driven development. So we'll write some tests, see them fail, implement the functionality, and then at the end, we'll do a little cleanup of styles to make it look the way it should. So we're going to, actually, we can show this in the file explorer. So currently, all of the components all of the Polymer components are in the elements directory. As I create new ones, we're slowly adding them to the components directory. So we'll create a new about block TypeScript, and there will be a corresponding about block test TypeScript as well. And hang on a second, the YouTube is telling me that I might be dropping frames. Stream status is low. I think that I need to work on tuning my video some. Yeah, David, I'm hoping that next month Apple will release a new MacBook Pro 13 or 14 inch that I can upgrade to. I think that would solve a lot of my stuff, a lot of my current computer woes. Let's see. Okay, so we've got those two files. They're currently empty. In this project, so I'm going to hide this file tree, the side menu. This project, I have added Jest for writing component unit tests. So do npm test, and then we're going to tell it to watch. So with the watch command, we can tell it to run only the specific file that we actually want to run. Well, that's no good. I'm trying to use a tablet to watch chat, but the tablet is not actually showing me chat. So that's not helpful at all. Once these tests are up, okay, so one of the things we can do with Jest is it has a bunch of different watch features. I'm going to hit P for filter by file name. Now it'll only run test files that contain about-block. Currently it's saying there's no test suites here, which makes sense because we don't have one of those. So let's put this over here. So let's do, we need a describe. The main kind of core thing that all web components will have is they will register themselves, or they will define themselves. So we can do it defines a component. And we can now expect web custom elements get. We expect that it will define an HTML tag about block. And then we can expect that that is defined. So we run this, we save this. Jest will automatically see that it changed since it's watching it, and tell us that it received undefined when it's supposed to be defined. So we need to actually define that component. In the actual component file, we can, let's see, export. We will export about block is actually a class. And this is going to extend LitElement. And currently it doesn't really have to do anything. So this defines the base class that we will put all the behavior in, but it's still not registering itself as a web component. If you're using LitElement in TypeScript, there's a nice handy custom element decorator that we can use to define the HTML tag and tell it to register. And once we add that custom element decorator to the class, it should now be defined. It should now be defined, except it doesn't help if we don't actually import. We need to actually import the component. If you don't import the component, it never actually registers itself. Just for fun, once we see the test pass, we can comment at the decorator just to prove that that decorator is actually what registers it. Okay, so it failed. We put the decorator back and save it. Now it should actually pass again. So we now have our first test written. It doesn't do a whole lot, but it's progress. Okay, so the next thing we want to do is we've seen that it will render a little bit of HTML. Let's do a little bit of test to make sure that that actually happens. Let's say it renders details. And I already know that this needs to be async because we will be using some awaits in it. I have a little helper function that I have defined called fixture. Essentially, we can give it a lit HTML template with the component actually in it, and then it'll make sure that that renders, wait for it to do its initial render, and then return it so that we can run test queries on it. So if we do, let's see, const, we'll need something off of the fixture, but let's do that in a minute. So we'll await fixture. If my editor is not going to autocomplete it, that's fine. We'll need HTML from LitElement. And so in here, we're basically going to do about block and about block. So that this fixture will simply render the component without really any additional details, and that's fine. We do need to import fixture, and this is import from, this is at the root. That's not right. Test helpers fixtures. Helpers. Come on, computer, you can do it. There we go. Now this is currently going to fail Jest because it's an empty test that doesn't have any expectations. Over. Oh, and actually it's complaining right now because the fixture does a little bit of basic checking just to make sure that there's something there for it to actually render. So we can define a very simple little bit of template. In LitElement, there is a render function. Return, and this needs to return an HTML template result. So if we just go to div, and then the current way that I have the fixture helper set up is that it requires a child element with a class container. I expect that I will change that in the future, but right now it works pretty well, and you'll see why in a minute. So now it should no longer throw an exception in the fixture. Oh, and it actually just doesn't care that there's no expectations in there, although ESLint does care. So we can just do a quick test to make sure that this actually works. We can expect that, let's say, one of the things that I have integrated into this project is testing library, which actually makes some pretty handy features available, like get by text, and that will pass that a container, and then the specific text we're looking for is hello, and then we will just expect to be defined. Container isn't defined yet, but it's actually one of the values that is returned by the fixture. Fixture will return 3 items. Element is a handler to the host component. Shadow root is the shadow root of the host component, and then container is the DOM element within the shadow root. And I return container because the testing library query methods require an HTML element and don't work on a shadow root. So you can't pass it a shadow root. So that passes, that text is there. This is obviously not what we actually want for our tests. So if we jump to the actual component text, we can say that, so if we grab what we expect the text to be from the original element, these look a little weird because technically most of the files in this project are actually nunjuck templates. So before it actually gets built for local development or deployed to production, all of these nunjuck variables are actually replaced with values from a JSON file. That's kind of outside the scope of this unit test, though. I don't really care that the unit tests don't need to test that processing happens. It just needs to test that the correct stuff in the component is rendered. So for the sake of testing the basic functionality of this, I expect that the title and the description will be there. And so if we save this test, it should now fail because in the component, the new component that we're writing, it only has the hello value. And it should fail. There we go. It failed. So what we can do is we can now actually we'll just get a head start by copying the template from the Polymer 3 version and put it into the new element. There are some areas in this that we will need to update, but we can do that as we progress through developing the component. And so now those tests should pass since the template renders what we actually expect it to render. And if I double check, hey, we're still streaming, so that's good. Make sure I'm not forgetting anything else that I wanted to demo before I go on to the next part. Okay, so the next part is we have the basic function, the basic template rendering. There are some more items. There are some more details in here. Maybe I will just I will test one more of them. I won't do all of them because it's kind of not exciting content. And if nothing else, I hear content is king. Or content can also be queen. So there are a number of other bits in here that should be tested that they actually show up. I will add unit tests for those later on. Okay, so we now have the basic content rendering. There is some interactivity in this element. I can actually show it to you here real quick. When you click on, this is actually a button, and when you click on it, it loads a video in a modal. That trigger is there's a click event, and that is then sets some state in the Redux store. So we want to make sure that that works. So we'll write a new test. It plays the video. This will also be async. And we'll need a similar fixture. Right. Yeah. And then, so this gets a little bit more complicated and gets into a little bit more of testing library and Jest features, which are actually pretty neat. The main thing we'll want to do is we're going to simulate a click using testing library that has a fire event feature, and then we say it's a click, and then it's going to simulate that click on get by text. We're going to pass the container to it. I don't know if I fully described this very well. The get by text, I think I actually have a page up here. So queries, get by, so essentially testing library will say, let's look through the DOM and get an element matching something. It supports a number of different queries. For example, I should make that bigger. For example, we're using find something with text. So like this is an element that has about in it, the text about in it, and then when you do a get by, it'll find that element. The way that I'm currently using it, I pass in the haystack essentially. So get by text takes a haystack of the DOM fragment I want to search, and then what I actually want to search for. And in this case, that is this call to action is the text that it will look for, and it will then it'll search for that button and simulate a click on it, essentially. So that will trigger the actual click to happen. When that in the actual function of the component, when that button is clicked on, it needs to it uses an action to set some state in the Redux store. So we'll do an expectation to make sure that happens. So we can expect an action, which we will get in a second, to have been called. We expect it to have been called once, and then we will expect that we'll also expect it's been called with a specific value, which we will fill in a minute. So what we actually want to test gets called is, so UI actions is imported into the old component, and there's a function that calls toggle video dialog action, and it passes a bunch of this data. So we are in the test code, we will need to import UI actions from in the Redux actions, and then we'll need to just mock. And then this is the way this works is action. So this tells Jest to mock whatever that import is. So this path has to match the import. One of the things that's interesting about this is that TypeScript doesn't have any concept of the side effects this mock has. So there's actually a library that we can pull in from a library called Jest. So that will look something like const toggle video dialogues is equal to mocked. And then this will be UI actions dot toggle video dialog. We do need to import mocked from Jest utils. Now this is currently not getting used yet, but this actually is what gets used in our expectation. So this is toggle video dialogues is now a mocked function in Jest, and it has the functionality we need to make sure that it has actually been called a specific number of times, that it has actually been called with specific values. And we can see from the test undefined. Maybe it just needs to run it again. Sometimes the tests that start running halfway. There we go. Okay. Sometimes I've noticed that Jest will run a test. If I save twice in a row quickly, it'll run the test on the first time and not rerun it for the second test, for the second save. And I think that's what happened here, where it was still rerunning it and didn't bother rerunning it after the last save. So now we can see that this mock look at the bottom of the test. The toggle video dialogues mock is expected to have been called once, and it was called 0 times. And that's correct. We do not call it at all in the new component. So from the old component, we will take this function. We'll throw it into the new component. We will make it private since it's TypeScript. And we will also need to import UI actions. And one thing you'll note is that TypeScript is now quite mad about what we're passing into toggle video dialogues, and we'll cover that in a minute. So we now have this play video function, and we need to actually use it. If we look at this button, this is the call to action button. It uses a paper button, and you'll notice this on-click here. That on-click style is the older Polymer version of how you define click handlers. In LitElement, we will now update it to look like that. So it's an @click, event name, and then, and this actually has to run off of here. And then we use the JavaScript string interpolation to actually pass the function. If we save this now, I think that should actually now pass the test. Oh no, it won't pass it. It now actually calls the Redux action as we expect, but it's passing the wrong value. We have a placeholder called with to do because we haven't defined what it should actually be called with. If we grab this is what it actually gets called with. Let me throw it over here and save it. That test should now pass, but TypeScript is very unhappy. And let's go check out why now. So if we look at the type definition for the toggle video dialog function, it says it optionally takes a value with, it optionally takes a property with a value of null. And that there's no point in passing a value, a null value if it's the only thing you can pass. So we're going to go update this instead. Before I do that real quick, so if we go do a quick search for this function, this Redux action, toggle video dialog, you can see that all of the places it's used actually have a full value. So there's not a point where it would actually get null as something, as a value that gets passed into it. So we're going to get rid of that, and instead we're going to define an interface. We'll define this as video dialog. And then right here, we will export an interface video dialog. Do the strings first. So those will be strings, and then these will be booleans, and interfaces end with semicolons. So that's now a video dialog that is now the type, the shape of the value that the toggle video dialog function accepts as its parameters. And if we come back to the component, it's now happy because this passes everything that comes in. One of the things that I like about this mix of Jest mocks and TypeScript is that for unit tests, I don't need to care about how the Redux action does what it does. It can have its own unit tests, and then TypeScript will enforce the API contract between what the about block calls toggle video dialog, what shape the value it gets, and what value the toggle video dialog expects. So if we were doing a refactor in the future and coming in and say, oh, video dialog also needs to take a timestamp that's a number, and that's where in the video it should start, and we update that interface, we come back now, TypeScript will tell us, hey, you're missing a value that's required, so you need to update that. So I think between discrete unit tests having their tests and then TypeScript defining interfaces between the different components and the different functions, I feel much safer about mocking more than you might necessarily feel comfortable mocking. Okay, so we now have the test passing. We expect that when we click on when we click on the element that contains the call to action test text, that the Redux store will get called via an action with the specific values we expect, which is pretty neat. One thing to keep in mind is, say that we were to add another call to action. I got too many in here, I think. Do I? No, that's right. Plays the other video. So if we were to go back in the future and update this component to have multiple buttons that launch different videos, and we save this, this test as it's written should now fail eventually, once my computer catches up. Oh no, I have, that's where I knew my indent was up somewhere. Okay, so now that the indent is, wait. I have oh no, okay, cool. TypeScript is just slow telling me that the syntax is wrong. So this second one fails. The second test expects to have been called times 1 for the second click now fails because it's actually been called twice. And so the way that we can fix this is we can add a before each and we can use we can take the mock that Jest has and reset it, essentially clear it. We'll clear it. So that means that after every example test in this file, it'll reset that call count back to 0 and make sure that all that gets cleaned up. So now that we have that passing, we can now get rid of that second test that we don't actually need. So now our mock's getting cleaned up in between each test. We have the functionality of this component now tested. We tested it renders, we tested it gets defined, we test that when you click on stuff, it interacts with outside components. The next thing we should actually do is use it in the app. It's used in the homepage component. We have about block. So with the definition of the new component with LitElement, we moved it to the components directory. So we change that, we save it. If we come back to that up more. Okay, so if we come back to the local development server version, we come down, we see that the new version is rendered, and we know that it is because the styling is all messed up. And that's because we haven't done anything with the styles yet. So what we can do is get rid of that home page. Don't need that anymore. LitElement handles styles with a static getter. Static get styles. And this returns it. Oops, that's an extra CSS that you need to import. So this is how you define styles in LitElement. I'm going to ignore this host because we have other. Actually, never mind. I'm going to take that with me. So this is all the styles for this component. In the old Polymer 3, it's in a styles tag, which is in the template that also contains all the HTML. So one of the nice changes is with LitElement is now you've got one block that's your styles and one block that's your rendering template. That's a whole bunch of extra new lines that I don't need. So if we save this, we jump back to the running demo. It now looks better. We can see that this text is bigger. The blue or the purple bars are back, but there's still a number of design issues. This needs more space. This button is not colored, so we need to fix those. One of the things that I have been working on that is kind of outside the scope of this video is I've been creating a themed element that is specific to this project. And essentially what it does is it loads the global site theme and makes it available in every component. So once I import that, I remove the LitElement because I'm not using LitElement directly anymore. And then we still want some local styles from the component, but we will also spread the super. No, that is not what you wanted to do. We'll also take the styles that are defined in the themed element, which actually we can go look at real quick. So this basically takes a bunch of theming and layout styles that are defined in other files and makes them all available in this one component, this one super component. And then the other thing we notice is that this defines host display block, so we can actually come in and delete this from the component itself. So now if we save this with using the global theme, we come back to the demo version, and now it all looks pretty good. Looks close to what it should be. One thing you might notice, so yeah, actually that looks fine. So that's most of upgrading the component. We have it tested, we have it styled. In the future, I plan on doing more testing that styles work as they are, but that's going to be future improvements to the project and are kind of outside the scope of this work right now. Maybe the last thing we should do is this project use Prettier to make sure that everything's formatted correctly. So we can I'll show you that working right now. Before I do that though, or to help illustrate that working, I'm going to commit the changes we have. So should git commit dash patch. So git commit dash patch is super handy, where every chunk that it sees, it'll say, hey, do you want to stage this to be committed? In this case, we changed homepage to import the new component, so we want that. We added a video dialog interface to the Redux action, so we want that. We use that new interface in the action function definition. We want that. And this is actually, it's once a commit message now, which is fine. We didn't need to do that yet, but we'll do it. So convert about block to LitElement. And then we'll save that. We'll notice that there is still, we didn't commit the actual to main component file, the main component file and the test file. So we'll go add source components. Those two are now staged. We will amend the previous commit because it's all part of that same chunk of work. So now it's all committed. The only changes are some temporary files that I have in the repo that are unrelated to this work. So now we can do npm run lint prettier. This will run the prettier linter to see if it matches everything. It looks like it has identified two files that do not actually match the behavior or the layout we expect. So we can run fix, and this will actually update those files. And the neat thing is that since we just committed the components, we can now do a git diff and see what changes prettier added. And I think this, maybe I will open it up in VS Code, and it will show, so slow. So you show it in VS Code, then we can see a little more clearly what changes actually happened. So it took this and split it out into 3 lines. That was one change that it did. And if we go look at, it fixed the imports to be from double quotes to single quotes. It added a trailing comma. And that was actually it. So we actually did pretty good with our formatting. So now we can append those changes or amend the previous commit to have them. I'm now going to push this up to GitHub. And on the Hoverboard project, I will go to create a new PR about block to LitElement. It is related to convert. It is help. Help is related to that. If you look down, there is an extra commit that will go away in the future. That was some of the fixture changes I did, and now we can see all these new components. Although we forgot to do something. Source, we need to delete the old one. All right, so we're going to remove the old element, Polymer 3, implementation. We'll amend that real quick. I'll git push Jest force since we amended that commit. Once that's done, we can create this pull request. If we go look at files changed, I need to refresh it again. Oh, it might actually have just, yeah, so it actually, Git thinks that we renamed it, which is fine, which is good. Yeah, so that's converting a Polymer 3 element to LitElement. One of the things that we didn't really touch on is, so in the about block, in the actual template, it is using some Polymer elements still. So like paper button is a Polymer element. At some point, I plan on upgrading that to be using the material components web, material design web components. But that's, I think, future work that can be handled on its own and is not necessarily tied to upgrading to LitElement. Cool. Yeah, so that's upgrading it. This project is open source. There's a bunch of conferences that are using it, and there are a lot of components that need to be upgraded. So if you have a few minutes, there's a issue that's pinned at the top of the issues, help convert to LitElement. As more and more components get upgraded, they're getting unit tests. You can see there's a whole bunch here that are available that can be upgraded if you have a few minutes, and there's a quick rough complexity that shows, oh, this is lower complexity or higher complexity. So if you have some time and you want to help out, please check out this issue. And if you have any questions, please hit me up on Twitter. I would love to chat. So thanks for watching, and have a good day.